Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 48 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Raphael kit for Raspberry Pi. The Sunfounder Raphael kit. Now, most of you guys probably already have your kit. If you don't have it yet, look at it down in the description. There is a link over to Amazon. You can pick one of these up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is I'm going to show you my solution to the homework assignment that I gave you in lesson number 47. And that homework assignment was to take our video feed from the Raspberry Pi camera and to overlay on top of it a bouncing box. So first of all, how many of you guys were successful? If you were successful, leave a comment down below. I am legend. And if you were in double chest bump, maybe even, and if you were not successful, leave the comment, I folded up like a cheap Walmart lawn chair, which if you did, it's okay, because what's really good is I'm going to show you how to do it. But if you really struggle and struggle and struggle and just can't do it, then when you see me do it, you'll have that aha moment and you'll understand it's a really, really hard problem. And then I see where the trick was, and then you'll really understand it. If you don't try and struggle and you just watch me, it looks easy when I'm doing it and you think you understand it where really you probably didn't understand it. But just as a reminder, let me get out of your way here. And then just as a reminder, let's look, this is what we wanted to do. You see, we've got the live feed from the Raspberry Pi, and then we've got this box that's bouncing around inside of the field of view of the camera. Okay, so let's jump in and let's talk about how I did this. But the first thing that I need to talk to you about is I need to talk to you about the right way to do this. And the right way to do this is to think like an engineer. And that's one of the things I'm trying to teach you in this class, is how to think like an engineer. And what I would always notice, I would give this assignment to kids in high school, and what they would do is they would be really gung-ho, like, oh man, this is really exciting. And just immediately they would get their kit out and they would get their keyboard and they would just start banging on the keyboard, trying to write the code, kind of making things up as they went along. No. You don't start by writing code. What do you do to think like an engineer? You get it to work on paper first, and then when you've got it on paper, then the coding is easy. So what do I mean by getting it on paper? I want to draw a picture of what I'm trying to do on paper, and I want to label that picture. And then I want to start writing some simple math that defines what's going on. And then when I have that picture done, then when I go over to the code, the coding part of it is really easy to do. Why? Because I mapped out a strategy and a picture and key relationships on paper. And then the coding is just a matter of not being silly and making a bunch of typographical mistakes, if that makes sense. Okay, couple of things here. Let me switch over to here. I got so many windows to keep track of. Now, what I don't want to do is I don't want to start completely from scratch. I want to start with that program that we ended up with a couple of weeks ago so that we can move this show along. And so what I can have you do is you can go over to the most excellent www.toptechboy.com, and you can use this happy little search icon, and you can search on something like calculating frames per second in OpenCV, and you'll come down here and you'll find this code that we developed a few weeks ago. You can just hit those little button there, and then you'll have your code. And then what you can do is you can come back over to your Raspberry Pi view, and then what you can do is you can paste that code in. And just to make sure that the universe is in proper working order, let's make sure we have what we think we do here. Yes, you see it's just me and it's just a boy in his frames per second. Okay, and that is what we were expecting, so I will quit out of that. And now what we're going to do is we are going to work out this problem on paper. Okay, now what do I want to draw? Well, the first thing that I have is I have a frame. I've got a frame that's coming from the Raspberry Pi. And so what I think I will, that is not what I wanted to do. I want to get this. And so what I want to do is I want to draw that frame, okay, like this. All right, so that is the frame. Now what I want to do is I want to start labeling some of the points. Now, right, we've got to think of that frame as columns and rows. And it is columns first and then rows. So if we define a point, the point is column, comma, row. And so what's the first thing that we should think about? Well, we should probably think about what is this corner up here. I need to turn that off. What is this corner up here? That is the point, what? Column 0, row 0. All right, so that's what that is. Now, if I'm going to define that one, I should probably define this one down here. Now, initially, you might say, let's go back and look at our program for just a second. And remember, in the program, we have defined how big that frame is. We've defined it as 2080 display width in columns and display height in rows. So it's display width wide and display height high, and display width, that's talking about columns, and display height, that's talking about rows. And so what you might, if you're not careful, what you might do is you might come down here to this bottom right corner and you might say that that is display width, comma, display height. But what you have to remember is since we started at 0, it's going to be 1 less than that. We didn't start at column 1, row 1, we started at column 0, row 0. So we've got to subtract 1 off of the other end. And this is just that old problem that computer programming starts at 0, and therefore you have to stop 1 before when you thought you would. And so this corner down here, what actually is that corner? That corner is actually display width minus 1, and then display height, display h minus 1. And right, that is going to be columns and rows. And I think you can see that well enough. It won't be behind me too bad. I'm very cognizant to try to not cover things up. I want you to be able to see them. Okay, now we got this thing going. Now what else are we going to have? Well, we're also going to have that little box that's moving around. And so let me see if I can define that box here. And that looks good. And now we need to start putting some labels on the box. Well, the box is going to have, I haven't used this sketchpad in a while, so I'm still getting kind of acclimated to it. So be patient with me. It's going to have a what? It's going to have a width. I'm going to call that box W. And then it is going to have a what? A height. So I'm going to call that box height. You see, I'm putting parameters on my pictures, which will then help me have variables in my program. All right, now this has got to have a position. That box can't just be a size, it's got to have a position. And remember, for a rectangle in OpenCV, it wants the position of the top left corner and the bottom right corner. So we need to go ahead and define that. And so what we are going to do is we are going to come over here, and what is this point going to be? Well, I've just got to label it, and I'm going to call it the top left C for column and the top left R for row. So TLC, TLR is what I'm going to call that. And I make little tl and then big C and little tl and big R. Well, then what is this going to be down here? Now, since we've defined box height and box width, you have to see that the lower right corner is not an independent point. It is a dependent variable because I've already defined everything I need to get that point. Let's talk about the column first. What is the column going to be? Well, it's going to be the upper left column plus what? Plus the box width. So I go to TLC, top left column, and I add the box width. So this is going to be TLC plus box W. And then similarly, what is going to be my row value of that point? What is my row value of that point? Well, that is going to be where I started, the top left row, TLR, plus what? Think about it. Plus what? Box height. So what have I done? I've started at this corner, and then I've come over by box width and gone down by box height. Now what I'm going to go ahead and do is I'm going to give a variable name for these two things so that I can kind of simplify in my coding. I'm going to call this then the lower right column and then the lower right row. But this is going to be defined by the one above it. All right. And so now I have those things defined. Now, what is this box going to be doing? Every frame, it's going to be scooting left and right a little bit, and it's going to be scooting up and down a little bit. So I need a variable of how much is that scoot? How many pixels am I going to move the box with each frame? And so delta usually means change. And so what I'm going to do is I'm going to call this delta C for the delta column. You know, how many columns am I going to move left and right each time? And then I'm going to call it delta R is going to be how many rows am I going to jump. Each time I move that box, am I moving it by one column at a time, 2 columns at a time, 5 columns at a time, or, you know, 1 row, 2 rows, 5 rows at a time? You know, how much am I moving each time? So those are 2 variables that I am going to need. All right, now this is the trick. When we hit the wall, we have to what? Change directions. So if delta C is +1, when we hit the wall, delta C needs to become what? -1. If delta row is +1 and we hit the bottom, what do we need to do? We need to make delta row -1 to switch direction. So basically, anytime you hit a wall, you need to make, if you hit a side wall, you need to make delta C -1 times delta C, change direction. If you hit the top or bottom, you need to what? You need to make delta row minus of delta row, and that way you'll change direction. So now, what are the times that we need to be worried about changing direction? Well, the first one is, let's look at the column. Okay, let's look here at this TLC. That is this column here. When this column here hits this, that's when we are going to need to change direction. What is another case that we would need to change direction? This TL, top left row, that's talking about this row. When that hits the top, we need to change direction. When else would we need to change direction? Well, if the bottom of the box would be TLR, the LRR, the lower right row, this one, when it hits here, you would need to change direction. And then there would be one more place that you would need to change direction. And that one last place you would need to change direction is when this, the right of the box, and that right of the box is this LRC, right? It's this value. When that hits here, you would need to change direction. So There are 4 conditions that we need to change direction. How many conditions do we need to write down? 4. We need to take that picture and we need to write an if statement. But what you can see is, what I hope you can see is, we can put the left and right conditions into one if statement, and we can put the up and down conditions into one if statement. So the first if statement is going to have the 2 conditions, left and right problem, and the second if statement is going to have 2 conditions, the top and the bottom problem, if that makes sense. So let's jump in and see if we can write this. And I'm going to try to get snazzy here, and what I'm going to try to do is write the condition in the color of the condition that I'm looking at. So this is the first one that I am looking at, and that is looking at that top left column coming over and hitting the left edge of the wall. So it's going to be top left column, and you could say, well, when that's less than 0, yeah, but what you have to see is I'm checking the condition that I'm fixing to do, and so I'm fixing to add delta C, and I want to make sure that if I add delta C, it doesn't put me off the screen. So I need to go ahead and check on the condition TLC plus delta C, because that's what I'm fixing to do. If that is a problem when that is what? Less than 0, right? We're looking for it to get less than 0 all the way over here. Now that's one condition that I would change left and right directions. What is the other condition? Or you tell me. This time we are looking at what? We're looking to see if the right edge of the box has reached the right edge of the frame. And then when would that be the case, or when would that be a problem? Well, that would be a problem. That would be a problem if the lower right column, again, plus delta C, if that is greater than that far right column. And that far right column is what? That is display. That is let me correct that. Display what? Width minus 1, right? Because we got to think about that minus 1 because we started counting at 0. Does that make sense? I think it does. So that is display width minus 1. Okay, now what is the other one that I would worry about? And this is columns, this is columns, this is columns, this is columns, and this is display width minus 1. Yeah, that's right. And you guys can see that all right. I wish I had more colors that would all show up well. Okay, now which condition am I going to do? Let's look at this top one up here, that if the top of the box is about to go off the top of the screen. So how would I do that one? Well, that would be the top left row. And where are we going? We're fixing to add delta C to it. Delta C. If that is less than 0, okay, that's the first condition. Or what are we going to look at now? If the bottom is about to go off the bottom of the screen. And so what would that be? If the bottom is about to go off the bottom of the screen, that would be the lower right row, right? The lower right row, our purple one here, plus delta C. If that is going to be, and I made a mistake up here. I said, no, that's right. Never mind. Everything's good. If that is going to be greater than what? Display what? Display height minus 1. Okay, display height minus 1. Does that make sense? This is the program right here. I mean, this is the program. And then each time through the loop, then I need to increment delta C and increment delta R so that the box will actually move. Okay, that is how it works. That is how we are going to do it. And so now that we have a strategy, now we are ready to jump in and code. And I think that the coding is going to be easy. If you didn't really understand what I was doing as I was going through it, pause the video, make sure you understand the picture. So we're going to come over here to our code, and what we're going to need to do is we're going to need to, we come down and we had given a weight of 3, let's see, we given a weight of 3, and now we have all the normal stuff doing. Let's go ahead and let's start setting up this scene. And so let's start by the box, right? I've got a box, and we said we had a box W. I'm going to set the box width to 250 pixels, and then we had a box what? We had a box height, and I'm going to set that height to 125. And then remember, we had that top left column and that top left row. And so where is that going to be? I'm going to have the top left column, and I'm going to have a top left row. Where are we going to start those things? I am going to start my top left column. It doesn't really matter where you start it as long as it's in the field of view. I'm going to start it at 50, and then I am going to start the row. What row will I put it on? I'll put it on row 75. So we'll just start kind of more or less up towards the upper left. Now I need to define that lower right column, right? The lower right column. And if you go back and you look at the picture, we define that lower right column up there in the corner. We define that as the top left corner plus the box width. Okay, remember this is where we're going to put in math what we had drawn on that picture. Okay, so this is where we're going to put in math what we drew on that picture. And so the lower right column is going to be equal to the top left column plus what? Plus what? The box width. Now, correspondingly, the lower right row is going to be equal to the top left row plus how much? Box height, like that. I think that's good. Things like this, you got to pause, and I'm looking at my picture and saying, did I really capture in the code what I drew in the picture? Because I know that I drew things in the picture right. Now, what were the other variables, right? I had a delta R or a delta C. The delta C, how many pixels do I want to move that box every time? I want to move it 2 pixels, and then I can have a delta R. How many times do I want to move it up and down each frame? I'm going to move it 2. Okay. Now we know we're going to draw a rectangle, so I probably need to put some variables here for that rectangle. How thick do I want it? I'll put a thickness is equal to -1. That will make it square. And then I'll put a I'll just put a R color like that. Our color, let's see if we can make it orange. And so what would orange be? Well, orange would be, and remember it's blue, green, red. Orange would be green and red. If we made it 255, 255, that would be yellow. That would be too much green. And so I'm going to put 0 for blue, and let's put 125. Let's make the green half as strong roughly as the red, which is 255. So that's blue, green, red. That's 0, that's 125, and that's 255. I'm thinking that should be somewhere in the neighborhood of orange. Okay, and so I've got my color set up there. And so I've got, I think, all the things set up. Now I got to go down, and I think what I need to do is I need to put my if statements in. So here we grab the frame. After we grab the frame, we put the frame rate on it, the frames per second. And now before we show the frame, we need to do all of our magic with our rectangle. So the first thing we need to do is we need to see, do I need to change direction? So we need to see, do I need to change direction? If I don't need to change direction, I just go and I add the increments to all of those 4 points defining the 2 corners. And then what I do is I show the rectangle. So first thing is we got to put in those 4 conditions. So if, okay, if TL, if the TL top left column plus the increment that I'm fixing to do, if adding that increment, if that makes that point less than 0, I'm going to want to change directions, okay? Or changing directions left and right in the column direction. Or what? Or if the lower right column plus what I'm fixing to do, the delta C, if that is what? Greater than the display width minus 1, because we started counting at 0. What do I do in that case? Well, in that case, I change direction. Delta C is equal to delta C times, and I like to force my order of operations with a parenthesis, okay? It's just times -1. Those parentheses make it a little bit more readable and a little bit more explicit. So if it's going to the right, if it's going to the right, then it's going to turn around and become negative and come to the left. If it's negative and coming to the left, then it's going to turn around and go to the right. All right, now I also have to take care of the up and down. So if top left row plus what I'm fixing to do, which is delta row, if that is less than 0, that means I'm going off the top of the screen, or if I'm going off the bottom of the screen, which would be the lower right row, plus what I'm fixing to do, delta R, if that's going to be greater than, it's fixing to come up off the bottom of the screen, so that would be greater than display height minus 1. Why are we minusing 1? Because we started counting at 0. And then in that case, what direction do I want to change? Delta R. Delta R is equal to delta R times minus 1. I'm actually trying to be kind of careful here because, you know, it's just hard to decode this, debug this code. So I'm trying to be kind of careful with this. Maybe a little bit more careful than I normally am. Okay, so now I've changed directions. If I needed to, either of the directions that needed to be changed have been changed. Now what do? I add the increment. I increment the position of the box. And so what do I have? Well, I have the top left column is equal to top left column plus what? Delta C. Now I have the top left row is equal to top left row plus what? Delta R, right? Now I also have the lower right column is equal to the lower right column plus what? Delta C. And now I have the lower right row, and that's equal to lower right row plus delta row, like that. I think that's all right. And now, could it really be that I'm ready to show my rectangle? I think so. So I'm going to do cv2.rectangle. Where do I want to put that rectangle? On my image IM. And then what is my upper left corner? My upper left corner, I've got to put in a tuple, and it is the top left column and the top left row, like that. And then comma, and then this is going to be the lower right column and the lower right row. See how easy it is when you have a picture to go from? All right, now what else am I going to have here? I am going to have our color. Make sure I did that right. Yeah, our color. And then what else do I have? I have the thickness, and then make sure I define thickness. Yeah. All right, so that should be solid, and then we close that out. All right, could it really be that easy? You see, the coding part went pretty quickly. Why? Because we thought like an engineer and we drew it out. Now, I was kind of careful, but there were a lot of places in there I could have made mistakes, so I will need you to all take a big swig of your jet fuel. I will need you to hold your breath. Oh, denied, denied. Ah, I didn't put the or in there. Okay, were you guys yelling at me there? Okay, up here, I did not put or. All right, hold your breath. Boom. Okay. Now, don't boom too much, though, because we want to see, do we actually bounce? Giddy up. But we got to bounce 4 times because we could have made a mistake on any one of those edges. Shazam! Boom! And we got to come down. We still got to get this other one. We got to bounce off the bottom, and then we'll check and see if we did it on the left correctly. And boom! Shakalaka! We got it. Okay, guys. Lend me some feedback. How many of you guys were able to do this? Did that go all the way to the top? I just, for some reason, got a strange feeling it didn't go to the top and bounce too soon. Let's make sure that it goes all the way. Now, there's a little white bar above there, but it should go all the way to the top of the green. I just want to make sure that out of the corner of my eye, no, that's good. That's good. Okay. Were you guys able to do this? Were you able to do it? Like maybe you did it or you did it, but it was ugly. Do you see how straightforward you can take something that turns out to be a pretty complicated problem, a pretty complicated thing, but if you just methodically draw it out, then it becomes not just a fairly straightforward, it becomes kind of a fun thing to do. And you see, I made very few mistakes in my coding, and I really kind of got to the solution pretty darn quickly on this. And so, guys, this has helped us to start thinking about these frames we're grabbing from the camera as data, and we're starting to think of them as columns and rows of numbers, and then we can interact with that matrix of columns and rows. How did we interact with it? Well, we put some text on it, and then we put a box, and then we're moving that box around that column row space. And next week, what I want to do is I want you to, man, you know, I do not like that camera isn't very focused very well. Let's go to this view. Crystal clear, crystal clear. Okay, so I want you to continue to start thinking of that frame, that image that we're grabbing, that IM that we're grabbing. It's a data array, and I want you to start thinking of it as an array of data. And next week, what we're going to do is we're going to come in and we're going to start working with that IM data set and start kind of playing with it and manipulating it and starting to be comfortable with that as a data set. Because if you understand it as a data set, then you can analyze it, you can manipulate it, you can study it, you can change it, you can start doing artificial intelligence, but you won't do that as long as you just think, it's a .jpg, and I don't think it's just like, don't touch it, don't think about it, step away from the .jpg. No, we're going to crack it open and we're going to start looking at it and understanding it. And believe me, it's very logical and simple to understand, and I'll take you through step by step. Guys, I hope you are having as much fun taking these classes as I am making them. If you enjoyed the lesson, give us a thumbs up. What would really be helpful if you would leave a comment down below. That will help me with the old YouTube juice. And if you've not subscribed to the channel already, subscribe. When you do, make sure you ring that bell so you'll get notifications when I have future classes coming out. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.